So interrupts, you've got your interrupt register, which is a type of status register, which stores details of any signals that have been received by the processor from other components attached to it. So won't be directly attached to things like through I/O controllers and things like that. So if the computer receives a signal basically that's asking the CPU to do something, then it's known as an interrupt because it's interrupting what the computer is currently doing, and it's going to then have to stop an action, well, or potentially stop an action, whatever the interrupt is. So some examples. So the interrupt signal is sent by a device or program to the processor requesting its attention. Here are some examples of possible interrupts. So things like a printer requesting more data, a user pressing a keyboard or a key or a mouse button, an error occurring when a program's running, an item of hardware developing a fault, user closing a program so it needs to be terminated, power supply detects the power is about to go off because then it will go through the process of trying to save as much of RAM as possible. And the operating system wanting to pass control to another user in multitasking. They're all examples, but there are thousands of them. But different interrupts for lots of different reasons. Okay, so you can understand that the CPU will be busy doing something, and you can understand there's many reasons why that then might get interrupted. And then it's what does it do? So it works by essentially adding an additional step to fetch execute. So while you've been taught fetch decode execute, it's essentially fetch decode execute interrupt. So what that means is do the fetch decode execute cycle, and at the end of every cycle, look at the interrupt register. If the interrupt register tells you that you need to be interrupted, even if you might be partway through a set of instructions you're executing, you need to stop and deal with the interrupt. So if the processor finds there is an interrupt, it stops what it's doing and uses what's called the ISR, the interrupt service routine. So essentially what this means is it will copy the contents of the CPU, all the registers and things, to what's known as the system stack. So it will copy it all over into this area of memory known as the system stack. If you've looked at stacks and queues, you can work out why that's a stack. So it will copy it into the system stack, and then it's essentially got an image of what the CPU was like with all the register content, etc. Then it can deal with the interrupt. Once it's done the interrupt, it can then go back to the system stack, load everything back in the registers, and carry on just as it were before it was interrupted. Okay, now this next bit's a bit harder, but this is for the sort of high level year 13. So sometimes an interrupt will get interrupted itself. So then that's why you think why it could be stored on a stack, because you can keep stacking up different sort of images of the CPU so that it can backtrack through them and make sure they're executed again in the right order. Now, the way if you get interrupted and you're already being interrupted, the way it works is it works on priority. So different interrupts have different levels of priority. So things like hardware faults are going to be very high up. Okay, user pressing a key on a keyboard is going to be low down. So these priorities will determine in what order these interrupts are executed. So if you've got 3 interrupts running at the same time, they will work in priority order. So the most important will get done first. The way the computer deals with them, and it's worth noting these words in bold because they're sort of hard words, but they could be sort of the separation between the top grades at A level. The way the computer deals with a specific interrupt is called vectored interrupt mechanism. So what this is each interrupt has a specific piece of code that needs to be completed to deal with it. So depending on what the interrupt is, depends on what piece of code is going to be run, a little bit like event-driven programming. So each interrupt, therefore, has a memory address for the first part of the instructions that it's going to have to access when the interrupt occurs. So basically, when the interrupt happens, it needs to know where to go to memory to get the relevant instructions. The method of pointing to this memory location is your vectored interrupt mechanism. Okay, so this vectored interrupt mechanism is referring to memory as a vector. Okay, and then you've got your start position of memory where you're starting these instructions and the length of the instructions being your 2 attributes of the vector. Watch the vector video if you're unsure of what I'm talking about there. So vectored interrupt mechanism is this idea of all these different bits in memory, and you have to go to the right area of memory depending on the interrupt, And the process of then running the appropriate code is known as your ISR. So your ISR is storing the contents of the current CPU into the system stack and then running the new relevant bit of code depending on the what type of interrupt it was. Now, that was quite a long video, but that is interrupts, quite a complex thing. But hopefully you can see this in action quite a lot when you're typing, if you're doing an essay or anything like that, and you type a load of keys and the letters aren't appearing on your screen, and then suddenly, after a few seconds, they will all appear. That's because your CPU was interrupted. While you were typing away, the CPU got interrupted by something else, so you got put on hold. You're in a buffer, and then once it had done what it needed to do, it got back to displaying your letters as you type the keys. Okay, so that's interrupts.